So you can look at the triangle, right? You've got R, you've got H. This is phi1 as well. So we could say phi1 is inverse tangent of R over H, right? Great. For example, if R equals to H, phi1 is what? Pi over 4, which you can almost see. So how do we figure out what the maximum bounds are on the spherical radius here? Well, there's where you have to get into the details of, the interrelation between spherical and cylindrical, right? Because the outer edge of the cylinder is easily stated to be R equals to R, right? It's R equals to R in cylindrical coordinates. What's the relation between the cylindrical R and the spherical rho? Remember, it's rho sine phi, right? So that does it for the blue one. For the blue one, I just put, I think R over sine phi, right? See, because rho is equal to R over sine phi. And how about the red one? What's the equation of the top? It's Z equals to H, right? But how is Z related to sphericals? It's rho cosine phi equals to H. So that's why in the other bound I would put H over cosine phi. So that's why you really don't want to find yourself needing to integrate something that's sort of natural in terms of spherical coordinates over a cylinder, because you have to set up bounds like this to do it. And it needs two integrations, right? One for the red, one for the blue. You add them together to get the whole cylinder. All right. What would force you to think hard about doing something like this would be, I don't know, maybe you're faced with something like the triple integral over the cylinder of something like cosine of x squared plus y squared plus z squared dv. I don't know, something like that. Something where you know that changing to spherical coordinates is going to put, and that's still not enough. I need that to like the, something where changing to the spherical volume element would give you a u substitution for the integrand, which wasn't there in other choices of coordinates. That might be a reason enough to do it, something like that. But I have to work pretty hard to force this change of coordinates, is my point. This is not quite the reason to do it. Okay, move on. There's a missing picture, but you've seen this question on your test 4, right? The question where I gave you integral, like the Pac-Man question. This is essentially the Pac-Man question. Find the potential function. Ow, man. Don't bite your tongue. It's not good. Let's see here. So, how do we find the potential? Talked about that. You guys did pretty well on that question on test 4, though. I have hope for that one. Let C be the counterclockwise square with vertices blah, 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 and blah. Calculate that. How do you do this? This screams at you, Green's theorem. If you listen quietly, you can hear it. And so let's see here. My P is y squared minus sine x squared. And my Q is x, so Qx is 1. So I get 1 minus 2y integrated over the unit square for that one. And then let's see here. Here's a sphere of radius r, centered at the origin, oriented outward. Calculate the flux. So what's the smart way to do this? Sphere is a what? It's a closed surface, right? It's the boundary of the ball, radius r, right? So this says, to me, this says use divergence theorem, right? So the divergence of f here is 3x squared plus 3y squared. So I would just have to integrate that over a sphere. Yeah? Might be good for us to do that, though. Let's do it. So this is the divergence theorem, or Gauss's theorem. And so we're supposed to integrate from 0 to 2 pi, integrate from 0 to pi, integrate from 0 to r. And my divergence was, what was it? It was 3x squared plus y squared. And then my dv, of course, is rho squared sine phi d phi d rho d phi d theta. Now this this is not allowed, right? I need to change this into what? What should I put here? This is 3r squared, right? Which is what? 3 rho squared sine squared phi. Because we know that, as I just erased over here, the relation between the radius, the cylindrical radius and spherical radius, is that the cylindrical radius is rho times sine phi, right? So what do we got? Integral from 0 to 2 pi, integral from 0 to pi, cleaning it up, integral from 0 to r. Looks like I've got 3 rho to the 4th sine cubed phi d rho d phi d theta. So let's see here. I get integral from 0 to 2 pi of d theta, integral from 0 to pi of sine cubed phi, integral from 0 to r of 3 rho to the 4th d rho. That works out to 2 pi times 4/3 times 3 r to the 5th over 4. Cool. So 2 pi r to the 5th. Now, I don't expect that you remember or put on your card the integral from 0 to pi of sine cubed is 4/3. I actually would like you to work that out because I don't think it's something that you just know. So here's how you do that. So when we integrate from 0 to pi, when we plug in pi, we get what? We get 1/3 of cosine of pi to the 3rd minus a cosine of pi minus 1/3 cosine of cubed of 0 minus cosine of 0, which, by the way, is, sorry, this is minus 1/3 plus, what is it? Aw, that's disappointing, because it would have canceled out so nicely. At least you weren't telling me about attendance. 8 pi r to the 5th over 5. There we go. The 3's at least canceled. Anyway, getting back to this, we end up with 2/3 plus 2/3, which is, of course, 4/3. Yeah. Because contrary to the opinion of many of you, cosine of pi is not equal to 0. Cosine of pi is -1, I assure you. I mean, if you're ever, not that you guys go to bars, but if you're in a bar and somebody wants you $10 that, cosine of pi is 0, you should be like, nope. It's -1. You can hold to that. You can get solid cash money on that one. Not usually the topic of bar bets, I guess, but not that I really have much experience, but anyway. With betting or bars, but yeah. Calculate the flux of the curl of F through the upward-oriented open cone. And then there's a bonus question. Often I ask a bonus question about the wedge product and the differential that I talked about that last day. That's a Stokes theorem problem. I would encourage you to, a lot of you got wrong. What did you get wrong? Let's look at what you got wrong. If I can find it. So the last problem on test 4 So by the way, the thing that I have not emphasized today but is actually kind of important is when I make the final for a given class, I try to go back and look at all the tests I've given you this semester, and I do try to echo some of the things which were on those tests, right? Especially if there's a problem that, like, a lot of people got wrong, I do try to check if you've taken the time to fix that. It's actually more likely that a problem that you got wrong on the test is on the final than one you got right. Because to me, part of the point of the final is to see if you fixed your mistakes. If you have, then I'm willing to erase them. But this was the Stokes theorem question on test 4, right? So I would encourage you to look at that and try to understand it. The thing I haven't talked about in this review session that's important is how do you actually set up line integrals, right, from the parameterization? And how do you set up surface integrals from the parameterization, right? Or, for that matter, how do you set up a surface integral with respect to ds, right? How do you calculate the surface area of a sphere? That's very much a question that I might ask you. We haven't talked about it until just now. And then there's one other kind of question that is on my heart to share with you, and so I will show you that if I can find it. I think it was in 14. I don't know. It's been a few years since I've asked this question. I almost never tell you guys stuff that's not on the final, but I'll tell you this much. I'm not testing limits. It's just not in my, they don't pay me enough. Sorry. If I got a raise, about 20% raise, I'd test limits, but short of that, I'm not going to do it. But let's see here, somewhere. This one's no good. Sorry, I'm going to have to go back further. Further still. Maybe back to the... At some point, I'm just going to have to tell you what I'm talking about. Maybe I've just made this up. Come on. See here, this is far enough back I hadn't given up on asking about limits on the final. It's like the last year I did it. This is a nice problem, though. The partial p, partial t, partial t, partial v, partial v, partial v for PV equals nRT. What does this work out to? You guys remember? It works out to -1. It works out to -1. It hurts my eyes as well. Sorry about that. Let's see here. Come on. Where'd you go, you stupid thing? Curses. My son was like, isn't that bad to say? I was like, no. He said, what are curses? I'm like, they're words you can't say. But when you say curses, it's not saying those words. It's saying words, it's the word which describes those words, which is not wrong. It's meta cursing, right? Which is meta okay. Let's see here. Or meta not okay? I don't know. It's curses. Let's see here. I give up. Somewhere, if you look at enough of my old finals, and you can't do that, but there exists. Remember those problems where we had ugly bounds, like from the square root of blah to the square root of blah and the square root to square root, like taking those and reinterpreting them in terms of cylindrical or spherical coordinates is something I do think you should be able to do. Those make nice questions. So I will admit that's something I was thinking about putting on your final. So. But yeah, I'm trying to make it shorter than the one we just looked at. That old one had 22 questions. Like, I don't want to grade that. It's 10 pages. So I'm, yeah. I mean, I'm giving you 3 hours, but I don't want it to take 3 hours, you know?